Hi everyone, welcome back. So let's now go ahead and find this term, okay? And hopefully we can get it as a function. Hopefully we can get it as a function of Reynolds number, okay, with respect to L. Okay, so let's go ahead and do it step by step. So again, our left hand side is average shear stress over 1/2 rho Vx infinity square. Okay, I should put the square in the V. Okay, so what's the definition of average shear stress? It's given right here. 1 over L times integral from 0 to L of tau W dx over 1/2 rho Vx infinity square. Do we have, I tell you something, a trick right here. So for part B, we have demonstrated something amazing, right? So why don't we use it? So part B, we have showed that tau W over this equal to 4 over square root 30 over Reynolds number right here. So why don't we use this term, right? We have to use what we have. It's how we can advance far. So in order for this to happen, I will have to make 1 over L is over 1 to L. I have to make 1/2 rho Vx infinity square appear. So if I borrow it, I have to return it. So 1/2 rho Vx infinity square dx over 1/2 rho Vx infinity square. Okay, I can, since 1/2, so since this term right here, y'all can see it, is a constant. 1/2 rho Vx infinity square has nothing to do with x. I can put it out. So 1 over 2L times rho Vx infinity square times integral from 0 to L of tau W over 1/2 rho Vx infinity square dx over 1/2 rho Vx infinity square. Okay, let's see, can we clean this up? Yes, we can. We can clean these guys, cancel out, 1/2 cancel out. So this become 1 over L's integral from 0 to L of tau W over 1/2 rho Vx infinity square dx. Okay. So what have we arrived at part B? Y'all recall that tau W over 1/2 rho Vx infinity square is actually 4 over square root 30 of real number square root, right? dx. Okay, do you agree with me? There we go. Yeah, so our left hand side is 4 over 30 over square root of Rex, and now left hand side originally is tau W over 1/2 rho Vx square. Okay, so we can use the red circle. Let's go ahead and use it. Okay, like right here. Now 4 over square root 30 is constant. I can put it out. Square root 30 times L inside just 1 over L, 1 over square root Rex dx. What is Rex? Rex is 0 to L. Is actually rho times Vx infinity times x over mu, right? dx. Okay, so you see square root of rho Vx infinity, mu is a constant. I can put it out, so it's become 30 times L times square root of rho times Vx infinity over mu times, which go from 0 to L, 1 over square root of x dx, right? Let's go ahead and evaluate this integral. Oh, by the way, y'all see it? By the way, before I evaluate it, y'all see something interesting. So okay, let me do something like this. So this continues to 4 over square root of 30. For L, I rewrite like this: square root of L times square root of L times rho square root Vx infinity over mu times integral from 0 to L 1 over square root of x dx. Okay, y'all see something? I can group these terms together. I can group on these together. So we get 4 over square root of 30 times square root of L times square root of rho times Vx infinity times L over mu times integral from 0 to L of 1 over square root of x dx. This term right here, what is this? Y'all see it familiar? It is actually the Reynolds number, but with respect to REL, right? Okay, we make it appear. That's the good news. So now let's evaluate the integral. Okay, I can rewrite this like this: 0 to L, so x to the power negative 1/2 dx. Okay, because 1 over square root of x is x to the power negative 1/2. I can keep on writing this: square root of 30 times square root of L times square root of REL. Reynolds number with respect to length. So integrand from 0 to L of x 1/2 negative 1/2 plus 1 over negative 1/2 plus 1. So it's equal to 4 over square root of 30 times L times square root of REL. So integral from 0 to L of x over 1/2 over 1/2 over 1/2. So let's rewrite, clean it up. So it's 4 over square root of 30 times L times square root of Reynolds number with respect to length. 1/2 I put it L, and 1 divided by 1/2 is 2. 4 times 2 is 8. Okay, and 0 to L square root of x, because x over 1/2 is square root of x. So if you plug in the integrand, it'll be square root of L minus square root of 0, which is square root of L. So A over square root of 30 times L times square root of REL times square root of L. Okay, can you simplify it? Yes, you can. Square root of L cancel L, cancel L. Sorry, it's kind of nasty. Let me write like this. So it becomes A over square root of 30 times square root of REL. If you write a little bit, it would be A over square root of 30 of square root of REL, and A over square root of 30 is approximately 1.46 of square root of REL. Wonderful, wonderful. So finally, we get an expression for the dimensionless group, the dimensionless number of average shear stress over 1/2 rho Vx infinity square, and that one is a function of the Reynolds number with respect to L, 1.46 over square root of REL. I appreciate everyone for your attention, and I'll see you in the next video for the last part. Stay tuned.